Okay, ladies and gentlemen, welcome to this video. In this video, I'm going to talk about how the human population has changed since 1800, approximately. So that's the last 220 years. So it has been a time of major changes. In 1800, we were 1 billion people. So in this video, I'm going to present to you why it has changed, how it has changed, and also how we're going to solve the potential issue in the future, because we cannot continue to become more people because we have limited resources, we have limited food, we have limited water, we have limited resources also when it comes to energy. So we need to do something about it, but it can be solved in a very, very good way. So let's look at this. First and foremost, the population from 1800 to 2021. And here you can see how we, around 1800, hit 1 billion people for the first time in human history. Is it exactly 1 billion people? Probably difficult to say, because back then we didn't have the modern technologies that we're using today to count how many people we are, but approximately 1 billion people for the first time. So it took, according to our knowledge, 200 to 300,000 years to hit 1 billion for the first time. And today, in 2021, we are almost 8 billion people. So here I have taken another graph, and it is showing global child mortality. It is a kind of rough statistics to look into, but also very, very important. This one shows the percentage of people who does and does not survive after they are 5 years old. So if you look back at 1800, approximately 40 to 45% of people who survived birth did not survive until they were more than 5 years old. That's a huge number, a huge percentage. That has fortunately decreased a lot. This is a major improvement for humanity. And now we are down to 5%, little less than 5% if I remember correctly, but approximately that. Today in our world is still too many people. I totally agree, of course. But it is a very, very positive development. You can talk about medicine, you can talk about general hospitals and the quality of hospitals. You can talk about better nutrition. You can talk about cleaner water. So many different factors. But you can see here that there is a correlation between the child mortality. When that goes drastically down, more people survive to become adults and they get children themselves, some of them, which means that the foundation for population growth is very much related to the child mortality. Of course, it's not the only factor, but it is a major factor. Okay, so here I have included another graph, and this graph shows on the x-axis the GDP per capita. It's an indication for the economical situation in a given country, and this is for 2018. And on the y-axis is shown life expectancy at birth. So if you were born in 2018, how long could you expect to live on average? We can see a tendency here, a very interesting tendency. If you follow the mouse, you can see that there is no country in this triangle area except Equatorial Guinea. One small country, an exception to the general tendency. This means, if you look at this triangle area down here, that there is no rich country with a low life expectancy. Okay, so if a country was located here, it would be very rich and have a low life expectancy. It does not exist. At the same time, you can make a triangle up here, which indicates that there's no poor country. You see low GDP per capita with a high life expectancy. So as a general rule of thumb in the world, the better the economy is in a country, the longer people do live. And we can see they are color coded, and the African countries are the lowest on this graph, which is not a good thing. And then we can see some Asian countries here, and you can see how they are color coded. Qatar has the highest GDP per capita, and if you look at the highest life expectancy, you find that to be Japan. Okay, now I'm gonna include a fourth graph here. So this is showing the amount of people every year from 1820 to 2015 that either lives in extreme poverty or does not live in extreme poverty. Living in extreme poverty means that you have less than $1.9 per day to live for. Of course, it's not exactly $1.9. There is a way to calculate that and adjust it to the given country, but it is still a very good measurement for extreme poverty. If you go back to 1820, we were a little more than 1 billion people in the world. Approximately 90% of them were living in extreme poverty. We had a different society structure. We were behind when it comes to technology. Huge part of the population, approximately 90%, were living in extreme poverty. Then the population is growing, and the amount of people not living in extreme poverty is growing. Look at this little green area here compared to today. If you go around year 2000 or the 90s, you can see that the amount of people living in extreme poverty was the highest, not the relative number in percentage, but the highest total number of people living in extreme poverty. But the last 20 years we have seen a very, very positive development where the amount of people living in extreme poverty is now way under 1 billion. And that's a great, great development. But let's just compare it to the other ones. Just before, as you see here, we talked about life expectancy compared to economy. Okay, so the higher percentage not living in extreme poverty, the higher, longer time people live on average. And that's very related to the amount of people we are gonna be. So you can see how all these relate. The child mortality that we talked about previously, when that decreases, more people come. That's a great thing. You can see a general tendency between life expectancy and GDP per capita. That's good to know. Good to know. And you can see how the world has evolved in a very, very positive way the last 200 years. So the next graph here I'm going to show you is very interesting when it comes to this. So it is showing the amount of time it took for the population in the world to increase by 1 billion. First time we hit 1 billion is estimated to be 1803, so 200 and almost 20 years ago. And it took all of human history to reach 1 billion for the first time. So that is 200 to 300,000 years. Then it took 124 years to reach 2 billion, and we did that in 1927. Then 33 years, 15 years for 4 billion, and then we reach a period of time here from 1975 until 2011, where it only took 12 years to increase 1 billion people. That's almost 100 million people per year. That is crazy fast. And here is the major problem with that. Of course, it's great that we have many people today, but we have limited resources. We have limited food, we have limited water, we have limited energy, and we have the entire global warming and climate changes problem to deal with. So in this video, I'm going to present to you a very, very good and positive way of solving that issue. So here you can see in the graph that they are predicting that in 2088 we are going to be 11 billion people. That is difficult to predict. It depends on many different factors, and I'm going to show you those factors in this video as well. So here we have a map showing the amount of children you get per woman in each country in the world. You can see that the highest number is in the sub-Saharan area, so Africa underneath Sahara. the Sahara Desert. You can also see that we have some other countries that are kind of orange in their color, and you can see the colors describe the number of children per woman in the given country. And of course, that's very important when it comes to population growth. The higher the amount of children you get per woman, the quicker the growth is. Well, it is a foundational factor. It's not all about that, but it's very, very important. So, if you see here again, that's the same as before, children born per woman. 2019, I have highlighted an area where the number is the highest. And then here, I found a map showing the natural population growth. And you can see here, if the country is, I don't know what to call that color, let's call it orange. If the color is orange here, then there's a negative population growth, which means that the total amount of people in the country is declining. Not much, but a little bit. And here you have some countries in this very, very light blue color, 0 to 1% population growth per year. Okay, so here we can see the countries in the world where the population growth is the highest. And those are the countries where we need to make sure that the population growth is stabilizing. So that is the most important factor when it comes to slowing down the population growth on a global scale. So now let's look into how to do that. That's a little tricky, but also quite simple at the same time. Here, I've taken a new map. We still have children born per woman, and I've still highlighted the same area. And what you can see here is that the area with the highest amount of children born per woman and the area with the highest population growth is also the area with the lowest BNP or GDP per capita. So what we need to do is we need to improve the economical situation in these countries that are highlighted. Well, it's not everything that we need to do, but it's a very important factor. Then, when the economical situation improves, the amount of children per woman decreases. And then the natural population growth will also decrease. And that will stop the increasing population growth on a global scale. And then you might ask, how to do that? And I'm not totally sure. I am not totally sure. But we need to improve the economical situation in these countries. We have located the issue. We know what the solution might be, but we're not entirely sure how to solve the situation. So, here is something called the demographic transition model. And that model might be able to give us an answer. Denmark was located in phase 1 in the 18th century, from 1700, and in that period of time. You can see here there's a purple line describing the birth rate, and we have a red line describing the death rate. If the birth rate is higher than the death rate, then the population increases. Pretty simple. In the beginning in phase 1, both the death rate and the birth rate was very high. We are talking about an agricultural society before the urbanization, before the Industrial Revolution took place in Denmark. We have a situation where the amount of food, there could be problems with getting enough food, problems with proper medicine, general hard living conditions, which means that the death rate is high. But that's also the explanation to the birth rate, because the families need to have a lot of children to be able to sustain themselves. It becomes like this cultural thing of getting a lot of children. There's no opportunities for education, so you often would get the first child at an early age. So both are very, very high. So this is what happens in phase 2 now. In phase 2, the death rate decreases. In Denmark, it happened because the food situation got a lot better. That's a very central part of that. But the birth rate does not decrease yet. And that is related to the fact that it takes a little time for the population to, I don't know if you can call it, realize that there's no need to get the same amount of children anymore. Okay, so then later, the cultural aspect about like how many children you get, some people might even have the opportunity for education and so on, but ultimately the birth rate will also decline, the death rate continues to decline, and then you end up in phase 4. And originally the figure or the model only had 4 phases, but a 5th one has been added later. So in phase 4, the death rate actually becomes higher than the birth rate some places, and then you have a declining population. In Denmark, we are between phase 4 and 5 right now, as we speak. So, if you look at the map here in the background that we looked at before, we have these countries in Africa and also a few other countries where the birth rate is way higher than the death rate. They might be located in phase 2. They might be. And the reason why they are located in phase 2 is also a little bit related to food, but very much related to medicine. Increased medicine. Increased health situation in general. So it's a little different than when Denmark went through phase 2 and other industrial countries. So many Western countries and other countries around the world have gone through an industrial revolution, and the development you see here in the demographic transition is related to the industrial revolution that's gonna make the economy better in a country because of the increased production, and living conditions over time will get better. So we need to take some of these countries that are in phase 2 and further develop them, maybe further industrial progress in the country. I am not totally sure exactly how to do it, but it is central that we take them from phase 2 to phase 3, because the difference between the birth rate and the death rate decreases, and therefore the population will not increase at the same rate. And ultimately, we would hope to be in a situation with a balance between birth rate and death rate. So, you might say, okay, this is a model. Do you have any proof? Here is some proof. This is the number, the actual number from Sweden from 1749 to 2010. So the actual number. And here we can see, if you look at the rates, the birth rate being the blue and the death rate being the red one, you can see that the death rate decreases before the birth rate decreases, as predicted from the demographic transition model. And then the birth rate later also decreases, and they come to some kind of almost equal state. This is a proof that this model is not just a theoretical model, it fits to many countries around the world and their history. Thank you so much for listening. I hope you have realized now that one of the central factors for stopping this population growth that we have at the moment is to take the poorest country out of poverty, so they get less children per woman, so the population growth is not as rapid as it is at the moment, and then hopefully we can end up in an equal state where the total amount of people around the world is stabilized. Thank you so much for listening, and take good care of yourself.